Hello kids! Today we have section 4.3, solve by factoring. Okay, our first thing that we always want to look for is, do we have any common terms, anything that's in common to both that we can pull out? Alright, if we have 32x squared plus 40x, they both have an x, at least one x in common, so I can pull an x out of both of them. And 32 and 40 are both divisible by 8. So I can pull out an 8 and an x. So we're kind of like undistributing here. So if I took out an 8x, what would be left over here? 8 times blank would get me to 32. 8 times 4. And we'll have an x here. And then we would need a 5 in this spot. 40 divided by 8 is going to be 5. So you can see that if I were to multiply this back in, we'd have 32x squared plus 40x. So that's the first thing you want to look for, especially if there's only two terms. If there's only two things. Or if there's three things. Okay, still very similar. The first thing you always want to check for is, can I pull something out of all three of them? Okay, when there's a number in front of x squared, it's a little more difficult. Just an extra step or two, but it's, it can make it seem a little more challenging. Okay, so we'd like to factor that out if possible. 2, 26, 80. They're all even, so I can pull out the 2 in the front. So we'll have 2 times parentheses x squared plus 13x plus 40. Much nicer. Okay, we can use our magic x. Okay, what multiplies to 40 and adds to 13. Give me two numbers that would multiply to 40 and add to 13. 8 and 5. Positive 8, positive 5. That's going to multiply to 40. 8 plus 5 is 13. So we're going to have 2 times x plus 8, x plus 5. Okay. So why don't you try this one on your own. Let's go with 2x squared plus 16x plus 30. Go ahead and pause and work through that on your own. Okay, hopefully you recognize to pull out the 2. X squared plus 8x plus 15. We're looking for what multiplies to 15 and adds to 8. How about 5 and 3? 2 times x plus 5 and x plus 3. Okay, on to the next one. What if we can't factor that out? We're going to be able to see that? There we go. What if we can't factor that out? Okay, I can't divide all three pieces by 6. I can't divide them all by 2 or anything really. Okay? We're still going to need to zoom in all the way, aren't we? So when that happens, you have to multiply the front times the back to get your top number, and adds to the middle number still. What multiplies to negative 30 and adds to 13. Okay, we're going to have 15 and negative 2. Alright, so there's two ways to proceed from here. One is a little bit longer, but it's easier to see what's going on. One's a little bit shorter and requires a little bit of magic. Okay? So let's do the long way first. We're going to use 15 and negative 2, and that's how we're going to rewrite 13. So we're going to split 13 up into a plus 15x minus 2x. Okay? Seeing how 15x minus 2x would still be 13x, I'm not changing the value of the expression at all. Just rewriting it in a different form. Alright, then we're going to put parentheses around our first two and parentheses around our back two. Alright, what's in common to the first two? In common to the first two, we could pull out an x, and 6 and 15 are both divisible by 3. So I'll have a 3x in the front. Okay, that will leave me with a 2x. So that would give me 6x squared plus 5. That would have given me 15 if I multiplied it back in. So once you have your first one done, we're going to use this as a big hint as to what that should look like. What can I factor out of this one to make it be 2x plus 5? We're going to pull out that negative, or a negative 1. And now it's a positive 2x, positive 5. Okay? So next we take the leading ones, the 3x and the minus 1, and they go in a set of parentheses. And the 2x plus 5, even though it's there twice, we're only going to write it down once. And there we go. There it's factored. Okay? So that was a little longer than our other option here, but you could kind of see the math playing out in front of you. Okay, where this other one is a little bit more math-magical, if you will. We're going to divide our answers here by our front number, by our A term again. We're going to divide by 6 and reduce our fractions. Okay, 15/6 would reduce to 5 over 2. Negative 2/3 reduced to negative 1 over 3. Okay. Whatever's on the bottom bumps up in front of x. So we would have a 2 in front of x plus 5. And then the 3 bumps up 3x minus 1. Just like what we had the other way as well. Two different ways, the same answers. This way is a little quicker, but it involves a little magic. This way is a little longer, but you can see it playing out in front of your eyes. Okay? Why don't you pause and try that one on your own. Alright, so we should be multiplying to negative 30 and adding to 7. What do you have multiplying to negative 30 and adding to 7? 10 and negative 3. Okay. Now you got your options. You can split up the 7x into 10x minus 3x and do it that way. Or for time's sake here, I'm going to do the shortcut. This would reduce to 2/3. This is going to reduce to negative 1/5. The denominator bumps up in front. We're going to have a 3x plus 2. And then 5x minus 1. If you'd multiply this out, we'd get 15x squared minus 3x plus 10x. That would give me 7x minus 2. Perfect. What if there are 4 terms, 4 items? Okay, just like before when we had to split this up and we got 4 things, we put parentheses around the first 2, parentheses around the back 2. And you might have to do a little rearranging first in your homework problems, but for the most part, this is what's going to happen. Okay, what's in common here to both? I can divide both of these by 6, and they both have an x. So we're going to pull out a 6x in the front, 3 minus 4y. Okay, our first one here serves as a hint. How can I make this one look like 3 minus 4y? What can I pull out of here to make this be a 3? Well, I could divide it by 16, and these both have z's. So we're going to pull out a 16z. That will give me a 3 minus 4y. Perfect, that's what we wanted. Those two match. So put our front 2 numbers in their own set of parentheses. go. Alright, another special type of problem, difference of squares. Now, a sum of squares only works if it's a difference of squares. So this is another little strategy, a little shortcut if there's two things. Earlier on, we looked at pull something out of both, right? We looked at pulling something out of both pieces. Well, there's nothing here in common that I can factor out of x squared and 25. Okay? But if you notice that you have a perfect square minus a perfect square, we got a difference of squares situation happening. Okay, look at what's the square root of this one? X. What's the square root of this one? 5. X plus 5, x minus 5. Ta-da, that's that simple. Okay? X times x will give you x squared. Minus 5x plus 5x would cancel out. 5 times negative 5 is negative 25. Okay? With all of these problems, and we'll flip back here and look at another one, if it was equal to 0, you'd have a zero product property. Something times something equals 0, it means one of the two somethings had to be 0. What would make this parenthesis equal 0? If x was negative 5. What would make this parenthesis equal 0? If x was positive 5. So these would be your roots, your solutions. Okay, don't overthink this one. What's it going to be? Hopefully we were thinking about x plus 9, x minus 9. And if it was equal to 0, we'd be getting negative 9 and 9 for our x's. A little bit trickier, 16x squared minus 49. You're like, oh, there's a number in the front. I must have to try to factor something out. Well, you can't factor anything out. Okay? 49 is a perfect square. And 16x squared is still going to be a perfect square. What's being squared to get me to 16x squared? That's going to be 4x squared. So we're going to have a 4x minus 7 and a 4x plus 7. It doesn't matter which one goes first, the minus version or the plus 7. Okay? Let's say this one equals 0. It's a little more complicated. Okay? You're looking at this. It's not quite as easy as just doing the opposites. But it's close. What would make this first one equal 0? You would add 7, or do the opposite. It was minus 7, you're going to plus 7. And you're going to divide by 4. Okay, for this one, you would have subtracted 7, done the opposite, and divided by 4. And you'll follow that same pattern the rest of the way for all of those types of problems. It's always opposite of the back divided by the front. We even did that over here. Opposite of the back would be a positive 9, divided by the front, divided by 1 is still 1, or 9, positive 9. Let's flip back here. Let's say this one was equal to 0. Opposite of the back, positive 1, divided by the front, 1/5. Negative 2/3. Okay? Same type of stuff if the problem was equal to 0 and asking you to solve. Final little situation. Just something to be aware of when you're doing these problems. If you might run across some perfect squares. If you don't recognize them at first, you'll still be able to do them. It's just you're going to do some work that you wouldn't necessarily have had to done if you would have recognized the perfect square. Okay? Like this one. What multiplies to 25 and adds to 10? You're going to get 5 and 5. You need to write down x plus 5, and they're the exact same thing. So x plus 5 times x plus 5 would be x plus 5, parentheses, squared. And then after you do a couple of those, you'd be like, man, I'm really doing all this. It's not much work, but I'm doing extra work. Okay, so the more that you pay attention to these and can catch these, the better. All right, so what do you think this one would be? Alright, this is going to be x plus 4 squared. And our last one, ooh, it's got a minus 6 in the middle. Be careful. X minus 3, x minus 3, or x minus 3 squared. Alright guys, there you go. Check your homework slip for your homework. We have 3 days of this. Odds, evens, and then challenge problems at the back. Thanks for watching. Hopefully this helped. We'll see you later.